All right, we're going to get started. Sorry to interrupt your music if you were enjoying it. We're going to start with a unified and efficient approach to energy management across the network. Brian Hedstrom from CableLabs. To my left. Thanks.
Thank you. Thanks. I'm Brian Hedstrom, CableLabs. I'm a senior architect there. So today I'm going to be talking about energy efficiency in the network. And when I define network, I'm speaking more about the service delivery network for service providers. And on energy management, it's more about the monitoring of the network and energy and power metrics. So for today's presentation, I'm going to present the problem statement, what spawned this work, and my use case. Look at the information model for the metrics, the data models, and those protocols for collecting the metrics, and then my specific proposed protocol, the collection interface using IPDR SP as the protocol, and then my overall application framework, and then wrap it up with my conclusions. So in terms of the problem statement, I guess this kind of all began with, it's kind of hard to put where it began, but where we started was the National Resources Defense Council put out a report back in 2010, and it did a study on set-top boxes, older set-top boxes, and found that they're not very energy efficient. They consume a lot of power. But more importantly is, if you've ever turned off your set-top box, the lights go out, but in reality they don't really turn off. So there's millions of set-top boxes out in the field for your cable service, your digital satellite broadcast service, your telco TV service, and this NRDC report, estimates, millions and millions. So there's, whatever mega kilowatt hour usage of these set-top boxes, even in the off state. So then this report triggered a Department of Energy docket on proposing an energy conservation standard for set-top boxes. And of course, immediately the industry came together and said, we need to solve this problem before the government comes in and regulates us. So we've been working to come up with standards on improving efficiency in set-top boxes. So device manufacturers are beginning to address this. But what I'm talking about here is we need tools in the back office to monitor the power in the network, and we need to address this in the back office using state-of-the-art technology and state-of-the-art design approaches. So looking at my use case, it is cable-centric here for this example. So in the bottom part of the picture, we have a service delivery network here, being a cable platform with, if we start at the edge, we have the in-home devices being a gateway. Let's say it's a video gateway, cable modems, voice modems, set-top boxes, and then we have a whole in-home LAN with routers, smart TVs, all these things which potentially are going to become green devices as manufacturers try to lower the energy usage of these devices. And then we move into the head-end devices, all the CMTSs, the edge QAMs. Then we move into the core backbone with router switches, soft switches. What I'm not showing on this picture is then enterprise networks and data centers, but it really still applies there as well. So this is the entire network. And then above the network is, of course, the back office and the network management layer the business and service management layer that's trying to do all the monitoring of the network and eventually control functions, which my presentation doesn't address, but it's the next step. Once you're monitoring the network, you obviously want to start controlling functions in the network as well. So I start off with the first step, and that is, what's the kind of information that we want to monitor in the network and eventually collect out of the network? So the first step in our process is, let's define a protocol-agnostic information model that represents a common energy management information model for the entire network. In this case, let's say the service delivery network. You probably can't read that, but what I've constructed here is the equivalent information model for the IETF's energy management SNMP MIB. They're going off and building an SNMP MIB for energy management, which in my opinion is the wrong approach. And I'll get to that because SNMP is, an old archaic protocol, and it's a data-centric, implementation-specific data model. We need to define an information model which is protocol agnostic that we can agree on as an industry, which is what this is conveying using UML class diagram syntax, showing the objects, their attributes, their associations, and it's not defined using a very archaic ASN.1 syntax that many people don't understand. We can all understand more readily this kind of syntax. So once we have a common model, we can then, if you recall the chart, the use case chart, we had different device types. We had those CPE devices, the edge demarcation devices. We had the head-end devices. We had the core devices. And then we could have the data center devices. We could have the enterprise network devices. So what we do with those is we create these interface profiles, which are views into the common management model. And these are then subsets of the common management model that are relevant to each type of device. So for example, a CPE often has a battery. For example, a packet cable or voice modem has a battery in it. Obviously, for when the power goes out, you want to make phone calls. So one of those objects that's showing there on the left side is a battery object, and a voice modem obviously has a battery, so it needs to include the battery object in its interface profile, but it may not include other objects in that tree, in that full model. The CMTS head-end network component view wouldn't probably include the battery object because it's connected to a redundant failover power supply. So from this we have sub-interface information models per device. From these information models that are now specific to each device type, we then create a data model which is protocol specific and implementable in the devices in the network by translating that into the data model of the protocol, management protocol of the service provider's choice. I've listed 4 here. IPDR, which is, well, I'm first listing them by the data model and then the transport that they use. So let me step through each one of these. So IPDR service definitions are based on XML schema. The transport used here is the IPDR SP protocol. And again, that payload is XML. And this is what I'm going to dive into deeper because this is part of my architecture. NetConf Yang modules are based on XML. That transport uses the NetConf protocol, and its payload is, again, XML. This is defined by IETF, both the Yang modeling language and the protocol is IETF standards. TR69 data models are XML-based, and the transport uses the TR69 protocol, and it's, again, based on XML payload, and that is defined, those are both defined by the Broadband Forum. And then finally, SNMP MIBs are defined with the SMI syntax, and the transport uses SNMP protocol. And the payload there is ASN.1 BER encoding, and those transport and data models are defined by IETF. So to talk about SNMP in depth, because it's the most widely used, let me first talk about the data modeling limitations. I guess one of the strongest arguments is that the syntax is very constraining, complex, and static in nature. It's not an extensible language. And you cannot define complex structures using SMI. For example, you cannot embed tables within tables. And as you know, with Cisco routers and et cetera, the configuration of these devices is a very hierarchical tree structure in nature. You cannot mimic that in SNMP MIBs. There's no support for operations in SNMP MIB SMI language. We often have to define this a write-only leaf that triggers an operation. It's very hokey. And there's limited support for versioning and revisions. A manager and agent really can't exchange what module version is supported by the agent, and you can't advertise capability exchanges between the manager and the agent. So in terms of the SNMP protocol limitations, anybody that's deployed massive networks with SNMP collection knows that it is not scalable. A big setback with SNMP is you cannot do atomic transaction for configuration. If you want a device to come out of boot and get its full configuration, cannot be done in SNMP. SNMP can only set a small number of objects per operation. You cannot do a backup and configuration restore with SNMP, and you cannot do validation of configuration before activating that configuration with SNMP. It lacks support for a connection-oriented management session. It's limited to UDP connectionless, and this can generate a lot more traffic due to retries. For example, a CMTS today has upwards of 3 million managed objects. Try configuring a CMTS using SNMP. It's not done today with SNMP, and it will never be done with SNMP. And also there's no support for multiple configuration data stores. SNMP cannot operate on a backup data store. It only operates on the running data store. Again, there's a limited set of protocol operations: get, set, get next. And operators out there that use SNMP, they know that V3 for security, it's very complex and difficult to deploy, and generally they just do not do it. So to talk about NetConf and Tier 69, the other newer entrants, XML-based entrants, these protocols were defined for configuration management functions, not bulk data collection. So they transport uncompressed XML. Therefore, it really leads to about 10 times the data size. So there's a much larger increased bandwidth on the management traffic, and a lot more processing time on those network elements that are trying to transfer that data up to the collection systems. So that leads me to the final protocol, and that's IPDRISP. This is the Internet Protocol Detail Record Streaming Protocol. It's a data record streaming protocol constructed, designed for bulk data collection. It was designed by IPDR.org and acquired by the Telemanagement Forum, TMF. And it's been put under their TIP, or the interface framework. They have something called the frameworks with an X on the end. TM Forum is a membership-based organization. However, this specification, set of specifications, is public. The link is given there, and it's public because DOCSIS, our specification in CableLabs, is obviously public, and we require IPDR, and therefore we've made IPDR specifications public. So the service definitions are those data models specifying the content that's transferred via IPDR. TM Forum provides guidelines on how you construct the XML schemas to define those data records. So that's also published by the TM Forum. So each industry follows those guidelines to construct their service definitions. So to give an overview, a quick overview of the protocol, you have the network devices out there in the service delivery network implementing, this is out by the customer, close to the customer, and this is what's collecting, measuring all the information that you want to measure. For example, in our case, we're measuring power, battery usage, whatever. This is where the exporter function is implemented. And I'll get to this in a minute, but we have, in the next slide, but we have different streaming methods that can be used. So I'm going to say, for example, 15-minute streaming. So let's say you're collecting battery information, battery usage information every 15 minutes. You're going to stream that information out via these IPDR data records to a collection system. And that collection system then transmits northbound these records, either in the XDR encoded format that it got them in, or it can expand those back out to an XML-based file format, and then it will push those northbound to a mediation correlation system or OSS system, like an energy management monitoring system, or let's say a power control system. So the power control system obviously has some policy management functions. Let's say in this case, it detects that there's X percentage of modems in the network that have been idle for 3 days, and it wants to put those modems into a low power state, and it can then affect changes back down into the network to put those modems into such a low power state. So what's the efficiency gained with this collection protocol? You can eliminate redundant information. Like with SNMP, you walk tables all the time. You're walking tables. But with this protocol, you have the ability to do template negotiation. So you can, when you're collecting records every 15 minutes, you don't have to keep collecting static data that never changes, right? So you can, the collector and the exporter can negotiate the information they want. As I was talking about the time interval, 15-minute collection, we also have an event-based collection. So let's say part of the network power outage occurs, and a piece of the network detects that outage. So an event occurs, he can stream some information out to a collector saying, I see part of the network is out. Or we have this ad hoc session, so this asynchronous event occurs and some streams can be sent up. Obviously, a bandwidth reduction, I kind of talked about this. We have these XDR binary encoded serialized compact data records. And I also mentioned the devices in the network. The resource utilization is minimized with this compact encoding. And more importantly, it's a push model instead of a pull model. With SNMP, you are constantly pounding the device with these walks of these tables, and the device doesn't get to choose whether he's busy or not. You're pounding it with a walk, and if he's busy and he's timing out, SNMP keeps retrying and retrying and retrying and keep pounding it. That can be a real problem. So with IPDR, the device gets to decide when he has the resources available to push that information up to the collector. IPDR is TCP-based, so you get to take advantage of the connection-oriented reliability of TCP. And then finally, we have the ability to have a redundant failover collector in the case that the primary collector goes down. Okay, so in terms of my framework, this is the kind of a high-level picture of it. So we have these layers here. At the bottom, we have the service delivery network with the different network elements. So let's say we have the CMTS's routers, and then maybe some CPE devices, maybe some set-top boxes. And they all implement this IPDR exporter function, or perhaps the set-top boxes are aggregated under a device that implements this aggregation and collection, and then CMTS exports that information out for the set-top boxes. But they're all doing the monitoring of the power utilization and battery statistics, energy monitoring, all the metrics we've decided and agreed on as an industry in that model, the information model that I showed with the battery and all those associations between the boxes. So the idea there is that we've standardized on the data model, the information model first, and then we translated that to a data model. That data model is now in XML, and it's in an IPDR service definition. So we've standardized on the information model, we've standardized on the data model. We're now using the IPDR SP standardized interface protocol. It's standardized by TM Forum to collect that data up to the element management layer. These are where the collectors sit. And these are highly available and redundant servers, very scalable, very efficient, as I've shown with the protocol. And then this information can be sent northbound to these mediation functions, correlation functions, where you're doing, you're doing a policy management on these XML records, in which I don't talk about, but then you can effect changes back down into the network for improving the efficiency of the network. Like the example I gave with, let's say, 10% of the modems are idle, and you want to push changes down to put those into a low power state. So that's the framework, all standardized based. So in conclusion, the point here is that we need a back office set of tools, open standards framework for lowering the energy consumption in the network. Service delivery network can be applied to a cloud-based solution using data centers. New tools are just the beginning, really. We have protocols today. I don't think we need to invent any new protocols to collect these metrics from the network. But we need to drive standardization of these information models and these data models. We do not want vendors to go off and define their own metrics and implement their own metrics. So that's the key that I'm trying to drive, is let's work as an industry to define these power metrics, these energy metrics. With these approaches, we can enable this service-oriented architecture that I've shown in the prior slide for monitoring these metrics. So even though I've shown a cable-centric use case, this use case can be used in any service provider network or any use case, I believe, that has devices out there in a IP-connected network. Thank you. 6 minutes for questions.
No questions? Okay.
All right,
Thank you very
thanks.
much.